Hello everybody, I'm Suman Matthews, and the topic which I would be discussing is indeterminate form of limits, which is a grade 12 math topic in differentiation. This video is recommended for grade 12 math students. Now, why would you care to watch this video? Because it gives you an explanation of how to evaluate indeterminate forms. This is a self-explanatory video and easy to understand. If you have any doubts, you can email me on, you can send it as a comment to me and I will try to explain it. Or you can email me at matthews.suman@gmail.com. As an experienced maths teacher teaching mathematics for the past 25 years, the topics which I would be discussing today are indeterminate forms of the type 0 by 0 and infinity by infinity, and as a bonus I will also discuss how to convert a problem which is not directly in the indeterminate form to the above types. So basically, what is an indeterminate form? If limit s extending to c fx by gx approaches the form 0 by 0 as extends to c, then you have the indeterminate form. So as extends to c, if limit s extending to c fx by gx is 0 by 0, it is an indeterminate form because as you know in calculus, division by 0 is not allowed. Now we have the L'Hopital's rule which is used to evaluate indeterminate forms, and this is without proof. It states that if fx and gx are differentiable functions, then limit is extending to c fx by gx. If it is of the form 0 by 0, it would be as simple as calculating limit is extending to c f dash x by g dash x, provided limit is extending to c f dash x by g dash x exists. A point to remember is this: again, if you get 0 by 0 form, again you evaluate limit as extending to c second order derivative of f by second order derivative of g. Again, if we have limit as extending to c fx by gx, which is the infinity by infinity form, this would be calculated by evaluating limit as extending to c f dash x by g dash x. So the same principle applies for 0 by 0 form or infinity by infinity form. Coming to questions, evaluate limit as extending to 0, x minus sin x cos x by x cubed. If we were to substitute x equal to 0, we get 0 by 0 form. So before we substitute anything, we just simplify sin x cos x. We know that 2 sin x cos x is sin 2x, so we multiply and divide by 2. So this becomes x minus sin 2x by 2 by x cubed. Taking the LCM, it is limit as extending to 0, 2x minus sin 2x by 2x cubed, again of the form 0 by 0. So applying L'Hopital's rule, this would be limit as extending to 0. Derivative of the numerator is 2 minus 2 cos 2x. Derivative of the denominator is 6x squared. Again, if we substitute x equal to 0, cos 0 is 1, so 0 by 0 form. So again applying L'Hopital's rule, it will be limit as extending to 0. Derivative of cos 2x is minus, so minus minus will give you plus sin 2x into 2, that is 4. By derivative of 6x squared is 12x. The 4 goes in 12, you can take out the 3. So it is 1 by 3 limit as extending to 0. Sin 2x, we know that limit as theta tending to 0, sin theta by theta is 1. So I multiply and divide by 2. So this limit becomes 1 and your answer is 2 by 3. Next question, evaluate limit as extending to 0, x minus tan inverse x by x minus sin x. Tan inverse 0 is 0, so again of the form 0 by 0 form. So applying L'Hopital's rule, it is limit as extending to 0, 1 minus derivative of tan inverse x is 1 by 1 plus x squared. Derivative of x minus sin x is 1 minus cos x. So it is limit as extending to 0. Take the LCM here, you get 1 plus x squared minus 1, and denominator is 1 plus x squared into 1 minus cos x. The 1 cancels out. So you get limit as extending to 0. Again taking the derivative of x squared is 2x. Here I apply the product rule. So I get 2x into 1 minus cos x plus 1 plus x squared into derivative of 1 is 0. Derivative of minus cos x is sin x. So that would be limit as extending to 0, 2x by, open the bracket, 2x minus 2x cos x plus sin x plus x squared sin x. That is limit as x tending to 0 to, again apply L'Hopital's rule, because when you substitute x equal to 0, you get 0 by 0 form. So it is limit as x tending to 0, derivative of 2x is 2, by 2 minus 2, apply product rule, you get cos x, plus x, derivative of cos x is minus sin x, plus cos x, again apply product rule, so I get plus 2x sin x plus x squared cos x. Now if I were to substitute x equal to 0, I get 2 minus 2. This would give you 1 minus 0 plus 1 plus 0 plus 0. So you will get the answer as 2. Question 3, again a question in grade 12 math indeterminate forms asked in the board exams. Evaluate limit as x tending to 0, x tan x minus pi by 2 sec x. Now this is directly not in the form 0 by 0 form, but if we were to substitute x equal to pi by 2, you get infinity here. So we just simplify it first. This is limit as x tending to 0, x, tan x is sin x by cos x, and sec x is 1 by cos x. Now we can take the common denominator as 2 cos x and take the LCM. So we get limit as x tending to pi by 2, 2x sin x minus pi by 2 cos x. This is of the form sin pi by 2 is 1. So it is of the form 0 by 0 form. So apply L'Hopital's rule. So we have converted this to a 0 by 0 form. So applying L'Hopital's rule, this would be limit as x tending to pi by 2, derivative of the numerator, which is 2. Apply product rule, so I get sin x plus x cos x. Derivative of the denominator is minus 2 sin x. The 2 cancels. If I substitute x as pi by 2, I get minus 1. So your answer is minus 1. Question 4. Limit as x tending to 0, 1 plus sin x raised to cot x. This is also not a direct problem where you can apply indeterminate form. So whenever you get an exponent, you start with let y equal to 1 plus sin x raised to cot x. Apply log to both sides. So log y equal to log of 1 plus sin x raised to cot x. Log a raised to m is m log a. So it is cot x into log 1 plus sin x. And so log y is log 1 plus sin x by tan x. Now if we were to apply limit as x tending to 0 of log y, it is limit as x tending to 0 log 1 plus sin x by tan x. So this is of the form 0 by 0 form. So we have converted it into a 0 by 0 form. Applying L'Hopital's rule, this would be limit as x tending to 0, derivative of log 1 plus sin x is 1 plus sin x, into derivative of 1 plus sin x is cos x, derivative of tan x is secant squared x. Substituting x equal to 0, I get 1. So I get log y to the base e is 1, so y equal to e. And you have called this as y. So we can say that your answer limit as x tending to 0 log y would reduce to just y equal to e. That is limit as x tending to 0, 1 plus sin x raised to cot x is just e. So for more videos on differentiation grade 12 maths, you can subscribe to my channel. Do let me know if this video or playlist has helped you. You can pass a comment.